Hey guys, it's me Ryan Rabi Anwar from ACE Academy. Since your O-levels examinations are coming up, ACE has decided to solve some nearly past papers to help improve your preparation. So today I'm going to be solving the Computer Science to May-June 2022 Variant 11. So let us start. Okay, so number 1. Jack has an MP3 file stored on his computer. A1, tick to show which type of data is stored in an MP3 file. So in your syllabus, you need to know of 3 lossy compressed files. Number 1, MP4, which is used to store video files. Number 2, JPEG, which is used to store image. And number 3, MP3 files, which are used to store sound. So essentially, we have to take sound. Now, number 2, tick to show whether the MP3 file is a lossy compressed file or a lossless compressed file, or not a compressed file. Okay, so essentially, lossy compressed files are used to reduce the file size and they cannot be reconstructed later on. On the other hand, lossless compressed files do indeed reduce the file size, however, they can be reconstructed. MP3 is a lossy compressed file, so we have to take lossy compressed file. So moving on, number 2. A computer is designed using the von Neumann model for a computer system. The computer has a central processing unit. A. Data is fetched from primary storage into the CPU to be processed. State the name of the primary storage from where data is fetched. So the CPU can directly access only the RAM. Other storage devices such as the SSD or any other secondary storage device cannot be accessed by the CPU. So the answer will be RAM, random access memory. Number 2, the CPU performs a cycle to process data. Fetches the first stage in the cycle. State the name of the second and third stages in the cycle. So essentially, the CPU processes data in 3 steps, in 3 stages. Number 1, the fetch stage. Number 2, the decode stage. And number 3, execute stage, right? So moving on. Number 3, identify 2 components within the CPU that are used in the fetch stage of the cycle. So during the fetch stage, what essentially occurs is that instruction and addresses are fetched or bought from the CPU using data buses or address buses into specific registers so that they can be decoded later on. So you could essentially include any register or any of the buses used in this stage. However, I have decided to include MDR, MAR, and you could also include other buses like data buses and address buses as well. Now, moving on, number 3. 3 types of storage media are magnetic, optical, and solid state. A. One example of solid state storage is a solid state drive. Identify one other example of solid state storage. One example could be your USB flash memory drive. You could also include other examples like SD cards. Now, B. Optical storage uses a laser to store and read data from a disk. Explain how the laser is used to store and read data from the disk. So essentially, a laser is shown on the disk, and the head, which essentially shines the laser on the disk, moves across the surface, and the laser burns pits on the surface, which allows it to read or record data on the disk, and to store data on the disk, and to read data from it, we have to shine the laser on the disk, and it is reflected from the pits and lands which were previously burned, and the reflector light is picked up by a sensor which allows it to be figured out, right? So moving on. C. A business is creating a new mobile device that has an SSD as a secondary storage. Give 3 reasons why an SSD is the most suitable secondary storage for their mobile device. Now there are numerous reasons. However, one reason is it is small in size. Number 2, it has a faster data access. Number 3, it has lower power consumption. Other reasons could also include the fact that they run at a much lower temperature and they have a higher capacity. Now, number 2, identify 2 examples of software that can be stored on the SSD. One could be the operating system, which is a system software, and another one could be any other application software like photo editing softwares or gaming software or GPS software. Now 4, all data needs to be converted to binary data so that it can be processed by a computer. A. Explain why a computer can only process binary data. So essentially, computers are made up of a bunch of logic gates which can only process 0 or 1, and they usually have outputs of two states, either on or off, which are represented by 0 or 1. So essentially, computers can only process 0 or 1, which represents binary data. Now moving on, B. The secondary values 64, 101, and 242 are converted to 8-bit binary values. Give the 8-bit binary value for each denary value. Okay, so to convert any denary value to binary value, what you need to essentially follow an algorithm. So first of all, you have to keep on dividing it with 2, and you also need to write the remainder on the right-hand side until the result 0 is reached. So as an example, let us take 64. So we divide 64 by 2, we get 32. We have to write the remainder 0 on the side. We divide 32 by 2, we get 16 and remainder 0. We divide 16 by 2, we get 8 and the remainder 0. We divide 8 by 2 and we get 4 and remainder 0. We divide 4 with 2, we get 2 and remainder 0. We divide 2 with 2, we get 1 and remainder 0. We divide 1 with 2, we get 0 and remainder 1. Now since we have reached 0, we have to stop and we have to take the remainders in a reverse order to get the actual binary value of that ternary value, right? So we have to write it down. However, remember that we have to store it as an 8-bit binary value. So to make it 8 bits, we have to actually place a 0 in the front of the binary value. Since 12 and remainder 1, we divide 12 by 2, we get 6 and remainder 0. We divide 6 with 2, we get 3 and remainder 0. We divide 3 with 2, we get 1 and remainder 1. We divide 1 with 2, we get 0 and remainder 1. We write it in reverse order, 1, 1, 0, 0, 1, 0, 1, and we place a 0 at the front to make it 8 bits. You could use the same process for 242, and you'll get the answer quadruple 1, 0, 0, 1, 0. Now moving on. The hexadecimal value 42 and CE are converted to binary. Give the binary value for each hexadecimal value. So now, to convert hexadecimal to binary, you essentially need to be able to convert each individual hexadecimal digits into their corresponding binary values. So for example, 42, you need to first convert 4 into its binary value, and then 2 into its binary value, and then you essentially just have to place them together. So 4 has a binary value of 0, 1, 0, 0, so we write down 0, 1, 0, 0, and then we write the value of the next hex digit, which is 2, which is 0, 0, 1, 0, and hence we also have to write 0, 0, 1, 0, and we get a final value of 0, 1, 0, 0, and 0, 0, 1, 0. So another example is with CE, right? So in the hexadecimal number system, the numbers 10 to 15 are represented using the letters A to F, respectively. So since we are given C and E here, we need to write their corresponding ternary values, which is 12 for C and 14 for E. And then we have to write their corresponding binary values, which can just then be replaced, and we'll get the binary value of 1100, 1110 for CE. Okay, so now moving on. Number 5. An image is stored on a computer. The image is 16-bit color and is 100 pixels high and 150 pixels wide. Calculate the file size of the image in bytes, show all your workings. The file size is actually given by resolution times color depth. The resolution represents the number of pixels in the stored image, and the color depth represents the number of bits which are used to store each pixel, right? So to find the number of pixels, we have to multiply the number of pixels in the height and the number of pixels in the width. So we get 100 times 150. And for the color depth, it is given that it is 16-bit color depth. So we have to multiply it with 16. And after multiplying it, we get 240,000 bits. However, since 8 bits make 1 byte, we have to divide by 8 to get 30,000 bytes, since we are asked to give the answer in bytes. So the final answer is 30,000 bytes. Now moving on. Number 6. A compiler and an interpreter are two different types of translator. One similarity between a compiler and an interpreter is that they both translate high-level language into machine code. Give one other similarity between a compiler and an interpreter. Now, one similarity is the fact that they both report errors, rather it be while the program is being run, in the case of interpreters, or before it is run while during the building process in the case of compilers, right? So now, number 2. Explain two differences between a compiler and an interpreter. Now, a compiler essentially translates code all at once and produces an executable file which can later be executed without using a compiler. On the other hand, interpreters translate code one line at a time and no executable file is produced, which means that you need the interpreter to run the translated code once again, right? So moving on. 7. Adult chooses to set a biometric password for her mobile device instead of a personal identification number PIN. See what is meant by a biometric password? A biometric password is a password which uses features that belong to a human. B. Give 2 reasons why a biometric password is more secure than a PIN. Now, a PIN is essentially things like the number password that you use when logging into your phone, right? This sort of passwords or pins can actually be guessed, and hence, but on the other hand, biometric passwords are not possible to be guessed since they include scans like retina scans or fingerprint scans, which essentially make it very hard to be guessed. And number two, it cannot be recorded by a keylogger. Now, keylogger essentially spies. It's a form of spyware, and it spies on the data that you type into your computer, which can then be sent back to a hacker or another third party, right? So essentially, whenever you're typing in a PIN or a password, this keylogger sends the data back to some other third-party individual, which makes it unsafe. On the other hand, biometric passwords do not do so, and hence making it more safe. Now, number C. Adele has a software-based firewall installed on her mobile device. The firewall gathers data about the traffic coming into and going out of her mobile device. Number one, it essentially compares data to set criteria, and if it does not meet the criteria, the data will be blocked, and an alert will be sent to Adele to warn her so that she's aware, and hence it will prevent hackers from gaining access. Moving on D. Adele also encrypts the data on her mobile device to keep it more secure. State how encryption will keep the data more secure. Now, encryption does not prevent the hacker from intercepting the data. However, since it makes the data meaningless, it actually makes it secure since it's useless to the hacker, right? So moving on. Number 8. Consider the following logical statement. X is equal to A and not B, or not B nor C and C. Draw a logical circuit to represent the given logical statement. Do not attempt to simplify the logic statement. All logic gates must have a maximum of 2 inputs. So whenever you're given to draw a logic circuit, you need to think of it in parts. For example, first you need to think of A and not B, then you need to think of not B nor C, then you need to join both of the outputs in the form of an OR gate, and then the output that you get, you need to pass it through an AND gate with C, right? So here I have labeled the different gates. However, in your examination, you won't really be required to label the gate. However, you have to be able to draw them. However, I have labeled them for the sake of understanding, right? So first of all, X is equal to A and not B. So first of all, this is the shape of an AND gate, and this is the shape of a NOT gate, right? So we have to pass not B and A through the AND gate, right? Then we have to think of not B nor C, right? So B nor C. Let us think of B nor C first. So this is the shape of the NOR gate. So we pass B and C through the NOR gate to get B nor C, and then we have to perform the NOT gate operation on it. So we do just that, B nor C, we pass it through the NOT gate, and then we pass the previous output and the not B nor C output through another OR gate. Now this is the shape of the NOR gate, we pass the output through an AND gate along with C to finally get our output X. So moving on, we have to complete the truth table for the given logic statement. So the truth table is essentially given for you to trace the values of each of the operations which is carried out. And once again, you have to do it in parts and segments. First of all, we have A and not B. The NOT gate, what it does is it essentially changes the value of the input, right? So if it's 0, it will be 1, and if it's 1, it will be 0. So it's 0, it becomes 1, this is 0, it becomes 1, 1 becomes 0, 1 becomes 0, and so on, to provide 1, 1, 0, 0, 1, 1, 0, 0, right? Then we have to think about A and not B, right? So what A and not B does is that what the AND gate does is essentially it provides an output of 1 if both the inputs are 1. Otherwise, it provides an output of 0. So A and not B, 0, 1 is 0, 0, 1 is 0, 0, 0 is 0, 0, 0 is again 0, 1, 1 is 1, 1, 1 is again 1, and 1, 0 is 0, and 1, 0 is 0. Okay, so now we need to next think about B nor C, right? So the NOR gate, what it does is that it provides an output of 1 if and only if you have 2 zeros as an input, and for all the other cases, it will provide 0, right? So we have B nor C, we have 0, and then 0, which is 1, 0, 1 is 0, 1, 0 is 0, 1, 1 is 0, 0, 0 is 1, 0, 1 is 0, 1, 0 is 0, and then again 1, 1 is 0, right? Next, we need to think about not B nor C. So we essentially have to perform the NOT operation on it. So 1 becomes 0, 0 becomes 1, 0 becomes 1, 0, 1, and so on until we get 0, 1, 1, 1, 0, 1, 1, 1, right? So oftentimes it's actually easier for you to give these very big operations like A and not B, and then not B nor C certain names or variables like X, Y, and Z, which essentially allows you to later perform other operations which will require these values, because it's not really possible to write A and not B, or not B nor C. Rather, you could just write that Z is equal to X or Y, which makes it much more simpler, right? So now let's think about Z, which is X or Y. X is A and not B, and Y is not B nor C, right? So 0, 0 is 0, 0, 1 is 1, 0, 1 is again 1, 0, 1 is 1, 1, 0 is 1, 1, 1 is 1, 0, 1 is 1, and then once again 0, 1 is 1, right? Then the final output X is given by Z and C, right? So Z and C. And now, as I've previously stated, the output X is 1 if and only if both the inputs are 1, right? So it's 0, 0, it's 0, 1, 1 is 1, 0, 1 is 0, 1, 1 is 1, 0, 1 is 0, 1, 1 is 1, 0, 1 is 0 again, and 1, 1 is 1. And hence we have a final answer of 0, 1, 0, 1, 0, 1, and 0, 1. Okay, now moving on. 3 internet terms are browser, internet protocol IP address, and uniform resource locator, URL. The 5 statements are given about the internet terms. Tick to show which statements apply to each internet term. Some statements may apply to more than one internet term. Now, it contains the domain name, which belongs to the URL. The IP address does not contain the domain name, as it is the address of a computer which is connected on a network, and the browser is essentially a software. Now, the browser, it is a type of software. It converts hypertext markup language to display web pages. Yes, it's a browser. And it is a type of address. The IP address, as I've said, is used to identify devices on a network, and the URL is the address of a web page, right? Which allows it to be sent back to the computer. Now, it stores cookies. Yes, browsers only store cookies so that they can contain information such as passwords, which allow easier access to the website itself. IP addresses and URLs don't store cookies. Now moving on, 10. Many devices have a media access control MAC address. Give 3 features of a MAC address. Now, a MAC address is essentially a physical address which refers to the network interface card, and it identifies the device on a network. Number 2, it is assigned by the manufacturer, and number 3, it is a unique address which remains unchanged throughout. Now, 11a. The paragraph describes the process of printing a document using an inkjet printer. Complete the paragraph using the most appropriate terms from the list. Not all the terms in the list need to be used. Now, data is sent from the computer to the printer. The data is held in a printer buffer, which is essentially a temporary memory location. Now, that is temporary memory storage until the data is processed to be printed, right? Now, inkjet printers operate by having a print head that moves the nozzles with side to side across the page. These spray liquid ink droplets onto the page. These ink droplets can be created using piezoelectric or thermal bubble technology. Now, if the paper jams in the printing process, the printing stops and an interrupt is sent to the computer. Now, an interrupt is essentially a signal which is sent to the microprocessor to stop what it is doing and so that it can service the interrupt. This is essentially important whenever you have, whenever the printer requires more pages or it requires another set of data to print, right? Now, B, a printer is one example of an output device. Give 3 other examples of output devices. Output devices essentially show the processes of computers in a output the process of computer in a way that we humans can understand. Now, there are multiple examples. One of them include monitors, speakers, LCD or DLP projectors. You could also include headphones in it as well. C, give 3 examples of input devices. Now, once again, there are numerous examples. The first one being keyboards, the second one being mouse, third one being microphone. You could also include examples like sensors, and then webcams or cameras as well. Now 12. Computer ethics are concerned for any users of the internet. Identify and describe 3 ethical issues that could be a concern when using the internet. So there are essentially 3, although there are multiple concerns, I here have discussed 3 of them. Number 1, hacking, which provides unauthorized access to computer. Number 2, spyware. And as I've previously mentioned, that keyloggers can be used to record key processes and send them to third party, which allows them to gain critical information such as the password of users or even other more sensitive data. Right? Now, number 3, phishing, which involves sending an email to lure users to a fake website and gain personal data. Other ethical issues such as farming or piracy could also have been written in this place, right? Paul? And with that, we have finished an entire paper. I hope that this has helped you guys. And if you have any confusion or any questions later on, feel free to ask. We'll be happy to help.